So here are the materials. You've got a completed version of the exercise in R, so that's kind of the equivalent of answers, I guess. If when you're doing the exercise yourself, you want to check the answers, you can unzip this and see how it's all kind of put together. I've got the project template zipped up file, which you can download from the internet, but it's there. There's a data file, an SPSS data file. There's a description. Now we've encountered this data set before. It's 25 personality items measuring the big five. So classic, case study in exploratory factor analysis to check that all the agreeableness items group together, all the conscientiousness ones group together, and so on. So we've got that. We've also got some metadata which describes the text for each of the items, and also whether the item is meant to be reversed or not, and also what factor it belongs to. Yeah. So that's all there. And yeah, then we've got the exercise itself. So we've had a little look at the description of the data. It's big five, 25 items, 5 items per factor. And we're going to use ProjectTemplate and RMarkdown to, I guess, clean the data, get it ready, and then run some exploratory factor analyses. So yeah, so the first thing we've got to do is obviously pull in the data. We've got to set up our project and pull in the data. So that's our first step in this process. So, okay, so we start with this project template, and I'll unzip that. Oops. Yep. We'll give it a name because we don't want to fill up our computer with that title, so we'll call it like EFA exercise or something. And I'll go into that folder, and I'll also change it there, so EFA exercise. It's a lot nicer if we open RStudio from this project file because all the working directory is in the right spot and everything kind of works. So we've opened it up, and yeah, we could open up the RMarkdown file. And this is the initial command that sort of gets it all up and running, isn't it? It's we load the project template package and we load the project. And if I were to do that, nothing too much would happen because there's no data yet in this project. So the first thing we've got to do is put the data file in and put the metadata into the data folder. So I'll just get rid of these other ones, we don't need them. So we've got the Excel, which is going to have the metadata. Well, it's already open, is it? Okay. So that's got the metadata, so we're going to pull that in. That might be useful if we want to incorporate that into any tables or know which items are reversed. We've also got this SPSS file, which I could open up, but it would take a while, so yeah. The names of the file determine what the names are in R, so it's nice to call them something short and meaningful. So I'll call it meta, and I'll call this raw cases. Okay, so now that those data files are in the data folder, when I load the project, hopefully we get something looking good. So we've got, so did it work? Well, we can see, did it import our cases? And it looks like we've got our 25 variables. These are the first few rows. And we could get the dimension just to check that it's got as many rows as we think. So yeah, it looks like it imported all right. We've got 2,500 odd cases and so on. And what about the metadata? That looks all right. It looks like maybe it's got some funny rows at the bottom. That sometimes happens when you're importing data from Excel. Sometimes it doesn't look like there's any rows, but there's just some empty ones at the bottom. So maybe I'll just go back here and delete those rows. I don't know. And that sometimes happens, you've seen it, and it's just a nuisance because it's not really missing data, it was just a mistake. So if we load it again, hopefully, yeah, that looks better. Yeah, so now we've got 25 rows. Okay, good. So as I say, the first step is to get our data into R, and that's achieved by putting the data files into the data directory, loading the project, and then you do a few checks to check that it all worked. Everything came through the way you'd expect. So that's a success. Okay, now the next thing we might want to do is kind of clean the data. If you ever get data from an online survey, you often get participants who've only done a few questions, who've skipped half the survey, have put in the same response for every question, so clearly weren't paying attention. So that you want to try and find how many of these there are, get rid of them, and move on. Sometimes there's more to it than that, but that's the basic idea. So let's see if we can identify the problematic cases, in terms of missing data or outliers. And as I say, the major split in the project template system is to put anything that's kind of processing the data file in the munge directory, and any analyses in your kind of RMarkdown files. So the logic for that is you don't want to have dependencies, too many dependencies. When you run your analysis, you want to be able to rely that the data's there, it's finalized. So all you have to do is run your manipulations once, and then you're good to go. So yeah, we'll start working in this this munge directory. This is where we're going to do our, look for cases with too much missing data and so on. As I've shown before, it's useful to create like variable lists because it makes it easier to select particular sets of variables. And in particular, we might want to have a list of all the questionnaire items in this survey. So if you look at the names of this data file, you see it's A1 to 05. So we could, I guess, pull them out like this. So dput puts it in a nice format, and yeah, you call it items. So then if we go raw cases, the items, it will just pull out those items. Okay, so there's a bunch of things that could be bad about a participant in this thing. And from experience, we know that lots of missing responses is one bad thing. Just putting 5 for everything or one, something like that would be bad. So these are all, I think, 6-point scale items. So let's see if there's any particular cases with lots of missing data. So if we use the apply function, it takes this, that's the data, and it's going to do something over each row if we put this 1 here. So this will tell us how many, for each row it says sum the number of missing values. So we could call this missing count. And what that's done is, if we get a table of it, so that's the number of cases with 0, 1, 2, 3 to 15 missing observations. So there's 25 questions. So if someone's missing 15 questions, they're probably not very good. We probably want to get rid of them. Maybe if you're really caring about your participants, you probably want to keep the ones that are only missing 1, 2, 3, 4, and so on, because yeah, there's probably still useful data there, and so on. But I'll be ultra cavalier and just delete all the cases with any missing data. So I'll keep only the ones with no missing data. Just because it's going to make it simpler with the next few steps I want to show you. Yeah?
Are you removing those missing cases from just that one variable or all the cases?
So I'm deleting those cases from the data file. Yeah, I mean, you could use different rules, but I'll just delete them all, just because it'll make a few things simpler. There's plenty of other things you could do here, and just to give you a quick flavour of some of the things you could do, you could say, I don't know, like what would be a problematic response profile? One that came to my mind was if you've got a 1 to 6 scale and some items are reversed, if everyone gave the same response to every question, I probably want to get rid of them. You know, if they gave all 3s or all 4s or all 5s, and they're reversed items, so you can't just agree with everything, because that would mean you're both neurotic and not neurotic or something like that. So I thought, oh, well, maybe we could get that. So instead of, there's a function called unique. And what that does is it gives you the unique values of a vector. So if that vector was the 25 responses a person gave, it tells you all the unique values that someone gave. And so the length of that vector would be how many unique responses they had. So we could call that unique count. And we could get a table of that. And we can see that most people have used all 6 response points. Some have only used 5, some only 4, and there's 4 cases that have only given 1 response. So we could see them. And there they are. So for whatever reason, a few people have given all 5s, all 1s. To be honest, with 2,000 people, if you had a couple of these dodgy cases in there, it's probably not going to matter too much. But at the same time, it's nice to be able to identify them and then pull them out. And so, yeah, I mean, this is a bit more advanced with the apply function, but you can sort of see the versatility, you know, that you can use different things to extract different features. So I'll just, yeah, I'll drop all the cases that have only got 1. So not equals 1. That's what I want. Okay, so anyway, you could do more. You could look at Mahalanobis distance, outlier measures, other weird behavior, but that's a good start, right? Okay. Something you might want to do when you're doing scale construction or you're developing a model and then you want to know how robust it is, sometimes you want to split your data file into exploratory and confirmatory kind of samples. This is done a lot in predictive modeling, because if you develop a regression equation in one sample, it will kind of over-predict your sample. And likewise, if you're playing around with model fits in SEM or CFAs and things like that, if you've got a big enough sample, it's sometimes nice to split it into 2. One for all the exploration, where you try 1,000,001 different things, and then finally, where you test your model. So I just wanted to show you quickly how you could do that in R. So essentially what we're going to do is we're going to use this function called sample. And oops. So it allows you to sample, I don't know, I'll show you quickly. So I can sample this. I could get 10, and we want to do it with replacement, which means it's not. Basically, each time you sample a value from confirmatory or exploratory, it doesn't remove it from the pool. So you can, I guess, this is a random sample, so it's randomly allocating potentially each case to either confirmatory or exploratory. So we could do that by ultimately, we need to give it the size, so that's the number of rows in C cases. And so it's given, it's assigned each person to a sample. And so we've got about 1,000 in each. Yeah, that would be a way of getting that. Just as an aside, if you wanted to make this reproducible so that each time you ran the code, people were assigned consistently to the same sample, you can do this thing called set.seed, give it a number. And that will ensure that although it's random in the same way each time, so that people always get assigned to the same sample. That's just useful if you want to make your results reproducible. So set.seed sets the seed of a random number generator. So you could put any number in here, oh, not letters though, and that would be a different starting point for the random number generator.
So it doesn't matter what the number is, so long as you set.seed.
Yeah, if you set it, that means that when you do anything that involves simulating stuff from randomness, it will be the same each time.
But the number itself doesn't actually change.
No, it's not. Yeah, if you change the number, you'll get a different random thing. But as long as you leave it.
So if you want your data to be reproducible, it doesn't actually matter what numbers
yeah.
started at. It's just that
yeah.
you know what number it was.
Yeah. And yeah, that means each time you run you don't have to worry about, oh, my EFA is changing each time I run this thing because it's generating a different random sample. So sometimes you want to have a different sample each time if you're doing like bootstrapping, but other times you want it to be consistent because you're trying to write up a results section and you don't want your numbers changing each time. Yeah. Okay, so we could then split our sample by this. And so this is put it into a list. So you've got two data frames now, one called split cases confirmatory and one called split cases exploratory. I'll work with this one, the exploratory sample, and just assign it to a new name to make it a bit easier to work with. Yeah. So this one looks like just looks like before, but yeah, it's got number of rows we'd expect. Okay, so we've got a data file that we can run some factor analysis on. So maybe let's just have a quick look at the items and see what's going on. You know, are there any items where everyone's agreeing or disagreeing? Are there any fundamentally problematic items in terms of means? So remember now we're switching not from looking at the data file and creating new variables, but to actually running some initial analyses. So we could do a number of things here. We could use the describe function to get means and SDs. We could use the sapply function to get maybe a table. So here we've got the frequency of each response. Or you could get the mean for each item. One thing you can do is start to build up a table. So we could make a data frame where that said mean. And we could maybe add the text from the metadata. And we could maybe look to see if there's any items where the mean was particularly large. So for example, it's a 1 to 6 scale, so maybe anything larger than say 4.8 or 5 might be worth having a look. So that there are a couple of items with slightly larger means where most people are kind of strongly agreeing, so it seems like most people are agreeing fairly highly with inquire about others' well-being and spend time reflecting on things. Yeah, maybe it's not too bad. There's still variability. Okay, so now we can move to maybe the exploratory factor analysis, and this is kind of where chunks would be used. So you might have this initial chunk that does your exploratory analyses, and then we'll separate that to the exploratory factor analysis. So we'll insert a new chunk. Okay, so what would you do if you didn't know how to do an exploratory factor analysis in R? You'd probably go exploratory factor analysis in R. And this is probably a good sign of what's good. QuickR is an excellent site. You'll find lots of nice little templates where you can pretty much copy and paste these kind of code and adapt it to your needs. So that's the general advice. I'll show you more specifically about how I do it. But the thing with R is usually it's not inherently obvious. Well, how do I do this? So you generally go to a template and then adapt it and so on. But well, yeah, one of the main functions, once you know the function, so factorNal is one of the main ones built in. It takes a data frame with the items and you tell it how many factors. So we have the items, that's the data set with the 25 items, and we might say 5 factors. And if we run that, we get some factor loadings and a few other things. But perhaps I'm jumping the gun. Perhaps we should have looked first, how many factors are reasonable in this data set? So there's a scree-plot function, which is nice. So we can get a look at the scree-plot and see that there's one large factor, then a second, third, fourth, fifth, definitely. And there's a little drop here, and then that sort of looks like where the scree starts, but maybe it starts here. But I'd say probably it's a clear 5 factors that are above the scree. But maybe there's a little jump there from 6 to 7 as well. So there might be something systematic going on beyond 5 at the 6 level, but it pretty much looks like there's one sort of global social desirability, whatever factor, and then another 4 meaningful ones. There's even something called the parallel test. Are people encountered parallel test where it simulates random data and looks at the number of the eigenvalues or various properties of random data and looks to see whether, to what extent the eigenvalues in your data are above random data. So if you apply that, it will do a bunch of simulations to produce random data, and it will tell us that in terms of factors, looks like there's 6 factors that are above chance, or 5 principal components above chance. So it's sort of reinforcing the idea that maybe there's some sort of little 6th factor that's just maybe sneaking above. And it might not be particularly interesting. There might be just some little effect, some small grouping of items beyond 5. But so it's suggesting maybe it's worth looking at a 6-factor solution. But equally, from the scree plot, it's fairly strong for 5, and certainly theory would tell us 5 is what this test was designed for. Okay, so we've had a little look at number of factors. So let's run this. One argument that's there is the rotation. So by default, it does varimax. So that's an orthogonal rotation where factors are not allowed to rotate. If for whatever reason I kind of like correlated rotations because I think they kind of make sense, that they allow the factors like extroversion, agreeableness to correlate, then you can do Promax as well. Okay, so I ran that the 5-factor model, and you can see the loadings here. By default, they're not that great, I don't think, but let's maybe do it. There's something called, if you go to the loadings function, there's different ways of printing it. So by default, it uses a cutoff of 0.1, which is a bit messy, I think. So maybe let's use 0.3. Okay, so if we have a look at that, these are the loadings. So we can see A1 to A5, it tends to be loading on factor 4. C1 to C5 is on factor 3, so that's presumably the conscientiousness factor. The E's are factor 2, and the N's are factor 1. Oh, and the O's are factor 5. So overall, it doesn't look too bad, does it? We've suppressed loadings below 0.3, but in general, bar 1, 2, so just 2 items, everything's loading highly, on what it's meant to be. So that's a good sign that the test is pretty good. We could have a quick look at a 6-factor solution. Just see what it was talking about there. See whether that's worth pursuing or not. And so if we ask for a 6-factor, it's got a bit of C4 and C5 and a bit of N4. You could possibly look up why that might be, see what it is about, do things in a halfway manner, and I don't know, have frequent mood swings and often feel blue. I mean, maybe there's some sort of depression factor going on there, or some sort of just negative item factor. I don't know. Not sure what you think, but it doesn't look particularly interesting to me. There might be something there, but it's probably not the main story. So let's focus on the 5-factor solution. You've got all the normal stuff you might be familiar with. So the uniquenesses, if you're familiar with communalities, these are just 1 minus the communality. So what's unique to the item? So this is saying 80% of variance in A1 is not explained by the 5 factors extracted, and so on.
Sorry, do you want to say that again? 8% of variance in A1 is not explained by
The factor solution. Yeah, so its communality would be 20%. So it's a measure of how well the factor solution, I guess, in this case, doesn't account for the item. So if anything, that's kind of the worst of all the items, I think. And that should largely mirror the loadings, that items with small loadings will generally be encountered poorly. So whereas the neuroticism items generally are kind of around 0.8, 0.9, there's quite a few high loadings that are well explained with. That agreeableness item is not as great. It's still all right, but it's not great. At the bottom here, you have your eigenvalues and also proportion of variance explained. This was with a Promax rotation, so that's fine, but you may, if you wanted to know the unrotated variance explained, you could do a rotation that says none. And so that tells you, and that looks a bit more like the scree plot. So the first factor was explaining 17% of variance. The next one was 9, the next one was 6, the next one was 5, the next one was 3. So if you want to get the unrotated solution, you kind of have to run it separately with rotation equals none. That will kind of tell us that, let's see. In an unrotated solution, almost everything loads on the first factor. It's kind of a general social desirability index, and then you get all sorts of other things going on, I guess. In general, rotated solutions are easier to interpret, and I would say in things like personality and climate reports, there's an emphasis on rotated solutions. Sometimes in the intelligence space, there's greater emphasis on the global factor, but I guess it depends on what you want to frame as important. It looks like it's kind of aligning well with the test. That in general, there's a few little quirks, but mostly the items are loading as you'd expect. So if you were going to interpret these factors, presumably they're going to be what you expect, that you've got an agreeableness factor, openness, and so on. So the basic idea is you look at the items that load highly, and you look at the direction of those loadings, and that indicates what those items are measuring. And it's pretty clear here, I think, because all the neuroticism items are loading highly on one factor and so on. So the most representative items of the neuroticism factor were N1, N2. So get angry, get irritated. So a general anger irritation factor is loading highly there. If you wanted to save the factor scores rather than scoring the test yourself, I think you can get those scores by just asking for them. Scores equals, I'll have to check the syntax, but you can ask for, say, regression-based scores. And then they should appear for everyone. So now you've got factor scores that you could then merge into your data set and use for subsequent analyses, like looking at age differences or gender differences. Alternatively, this could just be used to justify a scoring, the standard scoring procedure of adding up the items and so forth. Yeah. So, okay, so we've done this all in ProjectTemplate and RMarkdown. So hopefully, if we run this knit PDF or something like that, it would just all run and look good. But we've got an error. So here's a good test of my ability to debug things in real time. First of all, I've asked for help, so that doesn't look good. Let's get rid of that. Yeah, so this is a good chance to sort of explore how you debug these things. So let's clear the workspace and load the project from scratch. We're still getting an error. And my guess is that it's because Excel's open. The Excel was open and it was... Yeah, and so that seemed to work now, so let's try again. The data file that was being loaded was open and that caused the issue, I think. Okay, so we've got all the output there in not a super attractive form, but it's got the plots and various analyses.